Machine Vision for Visually Impaired People, Chapter 5, Optical Character Recognition, or OCR. In 1976, Stevie Wonder was the first customer of the Kurzweil reading machine, a device that allows a blind person to place a printed book on the machine, scan it, and hear it read aloud. That was the first commercial print-to-speech, or text-to-speech, as we call it now, machine. The very first radio song that I remember well, and that I listen to this day, is Sir Duke by Stevie Wonder. That was from his 1976 album, Songs in the Key of Life. It was released as a single in 1977. It got a lot of airplay, went to #1. In about 2003, a colleague presented me with a hard problem. Random alphanumeric characters, that is alphabetical characters A through Z and numeric characters 0 through 9, etched into steel. That steel then rusted, and a customer wanted to read those with a machine. This is hard to solve. The shapes were somewhat irregular. The rust would cause problems with the edges of the characters. The contrast that you would get on this is inconsistent. This was relatively difficult to light because it also occupied a relatively large space. And if you don't light something like this properly, by that I mean provide illumination that comes in at a certain angle from certain directions and so on, you're not going to get characters that are easy to read with an optical character recognition OCR algorithm. If you have OCR trained for a very specific font, for a very specific set of characters, then you will have effectively optimized for that set. For a machine vision system that's working in industrial capacity, if it's going to be reading the same characters over and over again, you do not want a generalized algorithm. You want an optimized algorithm. So machine vision, you're typically going to work on optimized solutions that are designed to solve a very specific problem. To get the most robust, most accurate system, you have to optimize for certain conditions. OCR libraries for smartphones and for generally computer vision are generalized. They may also do a semi-decent job at reading handwritten characters, which can be quite difficult, even for Latin script, which is the script that we use A through Z in Arabic numerals 0 through 9 for speakers of English and many other European languages. It occurred to me that this approach that I was working on, which I'm not going to describe in great detail, might work for people who are blind. We're going to jump ahead to 2011, and I actually left my full-time job to work part-time on this OCR algorithm. I wanted the algorithm to be able to read handwritten and machine-printed characters. These are actually two, at the time, these were still two different separate lines of development, inline and offline OCR. I also wanted to be able to read all scripts, Latin, Japanese, traditional and simplified Chinese, many of the Indian scripts, and so on. I wanted these to be fast, low memory usage, not require a Wi-Fi or cell connection. Those were some of my constraints. Be sure to read textbooks and papers by speakers of Japanese and Chinese, and nowadays also from India, because they are dealing with some really difficult scripts. After 2012, it became clear to me that machine learning, deep learning, and so on would clearly be the dominant techniques. In late 2020, I started working with OCR again on the iOS app that was originally named Point and Speak, that is currently now the Acrobatics app. The OCR library for iOS ran just fast enough on my old iPhone 7 this to be useful. And there were other OCR libraries available at the time. Tesseract didn't have the performance, it would have been too hard to integrate. And I wanted and continue to insist that the Acrobatics app, as it exists today, runs without a Wi-Fi or cell connection. That is, everything runs on the phone. If you're deploying OCR on iPhone, Android, or some other mobile device, make sure what you're doing runs on the oldest phone in wide use. Check statistics online for phone ownership of different phone models and look at the oldest model, which will be associated with some operating system version, and make sure you support that. You might say, oh, I'm just going to support new phones. That means, and there's nothing necessarily wrong with this, you are targeting early adopters, the people who have the latest technology. Let's turn to machine learning-based OCR, which is dominant for many applications right now. Now, you may use a vision software library that simply takes an image as input and provides words and word positions within the image as the outputs. Now, for mobile development, that is iPhone and Android, the way that the vision software for OCR is implemented could be something like this. There is a core OCR model for character recognition. There is software logic and/or a machine learning model to bundle characters into words. Then you have spelling check, which we typically experience as autocorrect on a phone. Then you may have a machine learning model to correct words based on recognized parts of speech in a sentence, such as noun and verb. And then further, you may have a statistically based method or machine learning model to correct words based on semantics, that is the meaning of a sentence. Some features could be bundled into one big model, or there could be a number of loosely coupled independent software components. With the Apple Vision library, you can actually observe words being corrected as the remainder of a sentence is being read. So the third word may have been read as ward, W-A-R-D, but as the rest of the sentence is read, and the third word is elephant, then it may actually realize that based on the parts of speech and the semantics, it may actually go back and correct a word it's already read, and it's going to correct ward, W-A-R-D, to word, W-O-R-D. And in fact, the character A and the character O are somewhat similar, so these letters can be confused. And that leads us to a discussion of accuracy. Accuracy per word is better when an image contains many words in a sentence or in multiple sentences. Accuracy per word can be quite good when an OCR algorithm can read printed text on a page of text, for instance, a page from a novel. Now, one disadvantage of generalized OCR that's made to read any number of fonts is that a short line segment in an image could be confused with the numeral 1. With an optimized library, that is a library that is trained for one specific font, for characters that have very specific shapes, it is less likely for that to happen. It can still happen, but you can try to design around it. For a generalized OCR library, you'll have to put up with some of this. The generalization means it's not going to handle edge cases as well. How would you solve that problem? If you are designing an OCR library and it is possible that an individual numeral 1 could be present, such as the 1 on a button in a number pad on an appliance or touchscreen, how would you solve that problem? Before you look and see how others have solved the problem, you think of how you solve the problem. I mentioned before, accuracy depends on context. So you could report the accuracy for words, correct word, not correct word, in sentences on a full page. Accuracy will tend to be quite high for modern OCR libraries when you're reading a full page, but that is only one context. You might consider the accuracy of recognizing individual words that are not in sentences. For example, on touchscreens, we have a lot of individual words. Accuracy will drop, and you've got to consider, how are you going to improve accuracy? You might also consider the accuracy by character, and here's where we see some real problems. 0 and the letter O, 8 and capital B, numeral 1, lowercase l. Other kinds of accuracy, you can think of alphanumeric strings that follow a pattern, such as serialized text, that is essentially serial numbers on products. Serial number can include alphabetical characters. So if those are going ABC 123, ABC 124, ABC 125, so the last digit's changing and then the next digit, or maybe you have only a few combinations, so a few valid combinations of characters, because you're expecting what the next character is. You might say, oh, okay, we've had a long run, we're on a production line, and we're reading ABC 123, ABC 124, ABC 125, and so on. You're expecting the next one to be ABC 126. If you're expecting ABC 126, you might allow a slightly lower confidence in the recognition of that character. Now, keep in mind, again, these are alphanumeric strings that are not words. This is harder. Common OCR libraries available now that are intended to read text on pages may not perform well and may, in fact, perform rather poorly within the context of industrial inspection on alphanumeric strings that are not words. The accuracy may need to be well above 99%. It may need to be 99.9%. In reading these strings, every character has to be correct. There is not necessarily a way to autocorrect it. And in fact, the next level of difficulty is alphanumeric strings with random characters. That could be something like a UUID or GUID, GUID. So some sort of unique ID, which could have been generated on the spot. You misread one character and there may not be a checksum. There may not be some logic to the characters. It could just be a random assortment of characters. So the accuracy there is if any character is wrong, the whole thing is wrong. That is a very stringent requirement. This is the kind of thing you encounter in machine vision where you have to add all this extra logic. And it's not just about having an OCR library. You have to consider the lighting. You could squeak your way up from 98% accuracy to 99% accuracy, which, think about it, that's twice as good. Just with the right lighting. And then you make some other tweaks and so on and so on. And you're trying to get to whatever the spec is. Let's say it's 99.9% accuracy. If you're going to fail 1 in 1,000 and someone's making 10,000 things a day, hopefully the economics work out. Any claim of accuracy about OCR must define the context for that claim to be meaningful. For your application, write down the target accuracy and the context. Are you dealing with alphanumeric strings, which is much more likely in an industrial context? There are a lot of really useful and largely forgotten nuggets that you'll find in older textbooks on optical character recognition and related fields. You should read those. I'm going to be mentioning a number of books here, and the links are going to be below. The Handbook of Character Recognition and Document Image Analysis by Bunke and Wang. The cheapest copy that I've seen online is $70. Look for this in an engineering library. Character Recognition Systems by Chariot. Reading in the Brain by Dehane explains how humans read all the processes. This is really complicated. So I strongly recommend you read this book. It will give you ideas. You want to be taking notes while you're reading these books. There is also The History of OCR by Shantz that came out in 1982, and you can find it free on the Internet Archive. And it's also cheap if you look for it. You should get it for like $6 or $7. Now, that book, called OCR a mature technology in the 1970s. For used books, I recommend you go to addall.com, ADDALL.com. I'm also going to provide some Wikipedia entries for more history about OCR. There is a blog post that includes drawings of historic OCR machines. That's quite cool. I'll mention, just to wrap things up, that OCR as I use it in the Acrobatics app for the Explore mode, where you're reading individual words at the end of your finger. If you recall what I was talking about before, reading individual words, not in sentences, and just at the end of someone's finger, it is hard to achieve high accuracy with that. In Read mode, which reading longer texts, for instance, a label on a shampoo bottle or on a soup can that someone's holding in their hand, that is longer text. Individual words will tend to have a higher accuracy, but for some labels, especially on foods, there may be individual words here and there. There could be the brand name. There could be the product name in some strange script. I am trying to keep up to date with changes in OCR as phones get faster and as machine learning models change. Google, Apple will simply provide a new version of the library that works better. You don't have to do anything. In other cases, you really need to look in and see, okay, is this library headed in a direction that's useful in my application? For the Acrobatics app, you use OCR together with hand detection. And that's what I'm going to talk about in the next video. Thanks. If you have a tricky OCR problem, you are already using a good OCR library. You have a system that you're trying to complete, or you have an application that is very tough and you're not sure you can do it, feel free to contact me. Go to acrobatics.com.